Hello and welcome to Math with Mrs. Becker. Today in pre-calculus, we are going to look at section 3.6, which focuses on inverse functions. Now, we have already talked about functions. Remember, a function means that your graph would pass the vertical line test. Every x value occurs only one time. Well, one way to represent a function is by using ordered pairs, okay? So if I have the function x plus 4, one way that you can show your solutions is doing like a set A, which represents x, and then set B, which represents y. That's what they're showing us here. So if x is a 1, 1 plus 4 is 5. Okay, that's why they're both listed first. If the x is a 2, 2 plus 4 is 6. If the x is a 3, 3 plus 4 is 7. So here's one way to show that function, to represent it. We are more familiar with the ordered pair notation. If x is 1, y is 5. If x is 2, y is 6. Okay, so when you look at this, it makes it pretty darn easy for us to find the inverse. To find the inverse, you interchange the first and the second coordinates. So if I have x, y, that's an ordered pair. To find the inverse, you guys, all you have to do is switch it. So now it's yx. Inverse means you're switching the x and the y. Here is the notation. So this means that you're finding the inverse function. That's what that little symbol means. Okay, you're just switching. Now remember, typically your domain is x, your range is y. So when you're taking your original ordered pair, the x values are the domain, the y values are the range. Well, when you switch the x and the y, what happens is the domain of the original function is now the range of your inverse. The range of your original function is now the domain of your inverse. They switch because, again, you're switching your x's and your y's, and those x's and y's actually have a meaning. So when you switch them, everything gets flip-flopped, okay? Let's go ahead and see what this looks like. If you are given a table, f of x, okay, so here's our table. Remember, f of x is interchangeable with y. So this means I have an ordered pair, -3, +10, -2, +6, -1, +4, 0, 1, 2, -3. If I want to find the inverse, you guys, all you do is switch x and y. So I take each ordered pair. -3, 10 becomes 10, -3. -2, 6 becomes 6, -2. -1, 4 becomes 4, -1. 0, 1 becomes 1, 0. 2, -3 becomes -3, 2. So again, all you're doing is switching that x and y value. These two are inverses of one another. Inverse simply means switch x and y. Okay, if you graph an inverse function, what happens is you end up with a reflection over the line y equals x. Now that's a diagonal line, because if you think about this, if y equals x, that means that they have the same value. So if x is -1, y is -1. So you'd be left 1, down 1. If x is 0, then y is 0. If x is 2, then y is 2. So this is that line y equals x. When you graph two functions that are inverses of one another, you need to have a reflection, like a mirror image, over that line. So what they're telling us is this is our function, and they're giving us the inverse function. Okay, so they're giving us both. They want us to sketch the graph to show that we would have a reflection over that line y equals x. So what I'm going to do first is go ahead and make a good old-fashioned xy table. This is for the f of x, my original function. I'm going to put in a -1, a 0, and a 1. Okay, if I go ahead and I do that, if I have 2 times -1 minus 3, 2 times -1 is -2, -2 minus 3 is -5. If I change the x to a 0, 2 times 0 is 0, 0 minus 3 is -3. If I change the x to a 1, 2 times 1 is 2, 2 minus 3 is -1. So I can go ahead and graph that on my coordinate plane. If I go left 1, I go down 5. So 1, 2, 3, 4, 5. Yeah, these are kind of, sorry about that, they're kind of labeled different. Okay, if I go 0, -3, so I'm just going to put the dot right by the label. If I go to the right one, I go down 1. So here is my line. Not sure why I printed that way. Okay, now here's the cool thing, you guys. We know that this is an inverse of this, right? Because they're both the f function. This is an inverse. You do not have to go through the work of redoing an xy table. What you have to do is simply take the xy table you made, flip the x's and the y's around. -1, -5 becomes -5, -1. 0, -3 becomes -3, 0. 1, -1 becomes -1, 1. This would be the inverse function. You just have to change x and y. So stinking cool. So if I go to the left 5 and I go down 1, again, I'm just going to use these little labels that are not lined up very good. -3, if I go to the left 3, I stay at 0. -1, up 1. So now when I go ahead and connect this, we want to see, do we have a reflection over that line? Well, heck yeah, we do. This would be a reflection over this, because if I go ahead and I extend this line, notice they do cross, okay, and it is a reflection over that line. So again, if you are given two functions and asked to graph them, find the ordered pairs for one using an XY chart. Graph that. Then if they tell you, hey, this is the inverse, just switch the X's and the Y's, graph it on the same grid, make sure that you do have that reflection. So that's the deal with graphing inverses. Now, if you are going to find the inverse function, okay, so if you're given a function and they say, hey, find the inverse, here are the steps that you want to take. You will change f of x to y. You have to do that because the definition of an inverse says to switch x and y. So you have to make sure that you do have a y within the problem. So change f of x to y, then you switch x and y, then you solve for y, then you change the y back to that function notation, but this time you indicate that yes, this is an inverse. So let's go ahead. If f of x equals 2x, step 1, change f of x to y. Step 2, switch x and y. So what was y is now x, where x was, that's now y. Step 3, solve for y. So I'd have to divide both sides by 2. So x over 2 equals y. Last step, change y to that notation. So our inverse function of x equals x over 2. Put a y in the problem, switch the x and the y, solve for y, show that it's an inverse. Okay, here's another one. Step 1, f of x becomes y. Step 2, y's become x's and x's become y's. So you switch them. Step 3, solve for y. So here I'd have to minus a 1. So I'd have x minus 1 equals 7y. To get y by itself, you divide everything by 7. So x minus 1 over 7 equals y. The last step, change y to that inverse notation. So the inverse of the x function, what is y equal to? X minus 1 over 7. Done. Kind of fun stuff. Okay, let's look at this. Now this time it looks a little bit harder because we have an exponent. You guys, it's the same process. F of x is y. So y equals x cubed over 8. That's step 1. Step 2, the y's become x's and the x's become y's. Now I need to solve for y. So step 1, I'd multiply that 8 over. So I would have 8x equals y cubed. Now in order to cancel a cube, you need to take what's called the cubic root. So that means you have a radical symbol with an index of 3. A cubic root cancels a cube. So y would be alone. This side is the cubic root of 8x. Now the last step, you have to go ahead and change that notation to show it's an inverse. So the inverse of the function equals whatever y equals when you got it alone. The cubic root of 8x. Done. Okay, well what happens if we have a square root? Step 1, f of x becomes y. Step 2, y and x change spots. So now it's x equals the square root of y minus 4. Now I need to solve for y. In order to do anything with y, I need to cancel a square root. Remember, to cancel a square root, you need to square because they're opposite or they're inverse operations. This cancels this. So I'd have x squared equals y minus 4. To solve for y, I just add 4. So x squared plus 4 would be y. Now your last step. Y is really the inverse. What is y equal to? X squared plus 4. That is the inverse function. So what that means is if you graphed this function and this function on a coordinate plane, they would be a reflection over that line y equals x. Super cool stuff. Okay, number 5. F of x is y equals 9 minus x squared. Next step, change y to x and change x to y. Now I need to solve for y. So on the same side of the equation as y but not touching is a 9. So step 1, I'd have to minus that 9 over. Now I need to get rid of that negative. So I can do that by going ahead and dividing everything by a negative. So positive x divided by negative 1 is negative x. Negative divided by a negative is a positive. 9 divided by 1 is 9. That equals y squared. Well, you guys, if I want to solve for y, I need to cancel a power of 2. To cancel a power of 2, you take the square root of each side. So y equals the square root of negative x plus 9. Y is the inverse function, so I go ahead and write it as an inverse. Done. Okay, now here's a tricky one. This is as tough as this will get, okay? So as you're looking at this one, this is kind of like a challenge problem. So f of x becomes y. X minus 1 over x plus 5. There's step 1. At this point, I know you're rocking it, okay? Step 2, you need to change the y to an x, and I need to change the x, there's 2 of them, to a y. Now at this point, I know you're still rocking it. Now here's where it's like, holy crap, what the heck do I even do, right? Because you need y by itself, I have 2 of them. Well, the first thing I would do, definitely get rid of the fraction. So if I multiply this y plus 5 to the other side, okay, if I multiply both sides by y plus 5, this will cancel. I would have to distribute the x, so x, y plus 5x. I got that by multiplying y plus 5 over here. Okay, I distribute the x to the y, distribute the x to the 5. Here, I multiplied by the denominator, so it canceled, leaving me y minus 1. Well, if I'm trying to solve for y, I want all the y's on the same side. So if I minus y, I would have xy plus 5x minus y equals negative 1. Well, here's the deal. These 2 terms have a y. This term doesn't. Get that term out of there. If it doesn't have a y, you don't want it with the y's. So at this point, this is what I'd have. I have xy minus y equals negative 1 minus 5x. What do these have in common? A y. So you guys, you can factor that out. If I divide both of these terms by y, the y would cancel. I still have an x. Minus y divided by y is 1. Equals, on this side, it's negative 1 minus 5x. To solve for y, I divide that over. So y equals negative 1 minus 5x over x minus 1. Last step, you have to realize that what you just found is the inverse. So you change the y to that inverse notation. Now I know a lot of people, this would drive them crazy because the x is second. Remember, you always kind of want it in that standard form. So go ahead and go negative 5x minus 1 on the top, x minus 1 on the bottom. That's as hard as this will get. This was like the challenge question for the section. Last thing that we want to be able to do today for inverses is prove them, okay? If you are proving that 2 functions are inverses of one another, you have to use composite functions. Remember, a composite is where you put one function into another function. When you simplify it, all you should get is x. And the trick here is you have to be able to go both ways. Take the original function, put the inverse in. Make sure it simplifies down to an x. Take the inverse function, fill the original in, make sure it simplifies down to an x. Okay, so here's an example. If my original function is f of x equals 4x, this says step 1, find the inverse. So y equals 4x. Switch x and y. X equals 4y. Go ahead and solve for y. So x over 4 equals y. So that is what the inverse is. The inverse is x over 4. So we have the original function and we have the inverse. To prove that these are really inverses, you take the original function, which is 4. Where x is, you fill in the inverse, which is x over 4. Well, the 4 cancels the 4. All I have is an x. Now I take the inverse function, which is x over 4. Where the x is, you fill in the original, which was 4x. 4 over 4 cancels. All I have left is x. So if you do both compositions, okay, you put the regular into the inverse and then you put the inverse into the regular, if they both simplify down to an x, you just verified or proved that these two things are really inverses of one another. If you graph these two functions on a coordinate plane, you will get a reflection over the line y equals x. If you find ordered pairs that make 4x true, if you switch the x and the y of the ordered pairs, it would make x over 4 equals true. Okay, so it's really, really cool. Let's go ahead. We have 3 more examples, and then I have a worksheet for you to do. If you are verifying that these are inverses, step 1, you have to do composite function. So if I take the first function, f of x, and where x is, I fill in g of x. So it was x squared, but instead of x, I'm filling in g of x. That's the square root of x. Square cancels a square root. It's just an x. Now I need to go the other way. Take the g function, fill in f of x. So it's the square root of x, but instead of x, I'm putting x squared. Well, you guys, a square root and a square cancels. They're both x. Yes, they are inverses. So again, using those composite functions that we have already studied, you put one function into another. Okay, let's do another one. F of g of x. So I take the f function, 3 minus 4, where x is, I have to fill something else in. I'm filling in this, 3 minus x over 4. Now when I simplify, this cancels this, you guys. Check that out. Because if you multiply by a denominator, so what this would look like now is 3 minus x. Remember, when you're minusing more than one term, it's very important that you remember that this negative has to go to both of those terms because you're subtracting that whole thing. So this becomes 3 minus 3. Negative times a negative becomes a positive. Well, positive 3 minus 3 cancels. All you have left is x. So it worked that way. Now we need to go the other way. Take the g function and fill in f of x. So 3 minus x over 4. Where x is, we want 3 minus 4x. So again, this negative has to go to both of those terms because you're subtracting a binomial. 3 minus 3, negative times a negative makes this a positive 4x over 4. Well, 3 minus 3 is 0. 4 on top, 4 on bottom cancels. It's an x. So you just proved that these two functions are inverses of one another. Last one, you guys, and that's 3.6. If I find f of g of x, so I take the f function, where the x is, I fill in g of x. So it's 8 cubic root of x. Well, here's the deal, you guys. When I go ahead and I do this, if I cube, this would cancel this, right? If I cube a cubic root, that would cancel. So I would have 8x over 8. Okay, cubic root cancels a cube, so the x is no longer underneath the symbol. 8 cancels an 8, that's x. Now if I go the other way, g of f of x. So 8 times the cubic root of x cubed over 8. Well, 8 cancels 8 because that's a denominator. Cubic root cancels a cube, so it's x. So the cool thing is just a lot of different things cancel. Cubic roots cancel cubes, like we see here. Square roots cancel squares. Anytime you multiply by a denominator, they both cancel. So you guys, that was 3.6. There is a worksheet that's due for today. I hope you enjoyed our time together, and I'll talk to you soon. Bye.